Today, inshallah, we will start doing on chapter 3. Chapter 3 consists of 4 subsections: 3.1, 3.2, and 3.3 and 3.4. And we will be beginning with 3.1, operating system view. Okay, operating system view. And inshallah, we will try to finish 3.1 today. Okay, right. So 3.1 talks about your process management. Okay, so we are going to understand what is process, what is a program, and we are also going to understand what is a task, job, multitasking, and what are the few states of a process. And we will be talking a little bit about how the process uh, will be handled by the operating system from the time it is brought into the memory until it's being run, until the process finishes or terminates by itself. So we'll be covering that in 3.1, and then the following class we'll do 3.2, 3.3, and 3.4, and so on. Okay. So what I would like for you to understand today is today we will be looking at 3.1, which is the process concepts. So we will be talking only about process, and the following and a little bit about tasking and also multitasking. Okay, what is a program? Okay, so a program is what we say as an inactive or passive entity. Okay, so meaning to say, if a program, before it starts running, it is called a program. Once you start double clicking on it, it becomes a process. Okay, so a program is what we say is a passive entity which is located inside your hard disk. Okay, so once you double click on it, so from the hard disk, this program will be brought over to your memory by the operating system, and it will be run by the CPU itself. Okay, so a program by itself is just a passive entity. It has nothing, it does not do anything, it's just a file by itself. However, to an operating system, a program, job, or task is a unit of work that has been submitted. Okay, so once a program has been submitted by the user to the operating system, then it converts from a program, it becomes a process. Okay, so that is the next subtopic on that. But we also need to understand what is a job and what is a task. Okay, so a job is what we say is associated with what we say is a batch system. So and a task is usually under multitasking. Okay, a task is much more easier to explain. A task is, for example, you open your Microsoft Word, Excel, and YouTube all at the same time. So what we say is you are doing 3 tasks at one particular time, whereby you open 3 programs at one particular time. So can we associate task and a program? Yes, we can associate task and a program, or we can associate task and a process by itself. Okay, so you can have several tasks running at one point in time. Okay, that's what we say as multitasking. You can also watch the TV, you can play your phone, and you can listen to music all at the same time. Okay, that's also called multitasking. But in the operating system's concept, multitasking is the operating system is running multiple programs at one particular time, or we can say running multiple processes at one particular time. For example, now on your laptop, you are running Google Meet, you are running your antivirus, you are running maybe your sound system speaker. So these are several tasks. A job, on the other hand, is a process, okay, which usually is done simultaneously together as one. Okay, it is not run. A job can only be submitted by the user, but cannot be operated or cannot be run. Once it's submitted, it can only run at one particular point of time. It's run together, okay, with other processes. Okay, so you can submit the job, but it's not being processed yet. Okay, It only start processing at one particular point of time. Okay, so that is a job. A task can be done immediately. Okay, that's the difference. Okay, what is a process then? So a process back to a program is what we say as a program in execution. So once you click on a particular program, it becomes a process and it's executed. So as opposite to a program, a process is what we say as an active entity. Okay, so task versus job. So in the 80s or early 90s, we have something which is called the Palm OS, Palm Operating System. So this is what we say as a small computer thing, okay, and it does not have the facilities like a smartphone. Okay, it's like a computer, but it can only do one particular task at one time. Meaning, you have Microsoft Word, you have a few programs here, but you can only use one program at one point in time. But now, most of the computer systems are designed by single user multitasking. So a single user is you and me, but we can do a few things running at one particular point in time, same as your telephone. A job, on the other hand, okay, you have a few jobs submitted by the user here, and the operator collects these jobs and batches them up together and runs at one point of time only. A batch system is something like when you get your monthly phone bill, okay, you only get it at the end of the month at a certain point of date. Okay, so the calls you made between the first day and the 20th day is all batched together and is only processed at the end of the month. Same as your electricity bill. You don't use your day, you don't get a bill for every daily usage. You only get a bill at the end of the month for how much electricity have you used. So that is what we say as a batch system. So what is a process? A process also includes stack. They have a temporary data. We have a data section which contains all the global variables, and we have some memory allocated to that process. So each process needs a small bit of memory to be allocated to the particular process for it to be run. Because we have to understand the process only can run inside the CPU. However, the files are kept inside the main memory, or what we say is your RAM. So there are two types of process which is highlighted by the operating system. One is the operating system process. Another one is what we say is the user process. Okay, so a user or a user process is executing user codes. However, the operating system process executes system codes. For example, it's much more easier to explain the operating system codes is, for example, if you are using antivirus, or if you are doing defragmentation, or if you are doing something regarding, let's say, you're doing the operation called copy, paste, rename. Those are all processes as well. So those are what we say is the operating system process. What is the user system, user process? A user process is whereby the user has control over the process. For example, when you open any application software, so the user has control over that particular process. As compared to the operating system process, the user does not have control over the antivirus, time, not your PC time, okay, and other operating system processes inside the operating system. Okay, so each process is unique by itself. Okay, each process is unique in the operating system, and it is known by the operating system as a unique and is given a special unique ID, or what we say as a process control block of the PCB. So each process has a unique process control block, and this process control block is unique to the operating system or unique to the process, and each process has a uniquely ID that cannot be saved with other processes. So what is inside the process control block? A process control block is a small piece of memory allocated together with the process, and inside this process control block, it has several information. As you can see in the screen, it has the process state, process number, counter, registers, memory, list of files open, and the pointer. Pointer means, let's say this process is now inside the main memory, RAM. Okay, what happens? The operating system needs to know what happens if this process shuts down. What should I do next? Okay, so if the process shuts down or is being closed, should I just close it, or should I move on to the next, to a totally different process, or so on and so forth? Process state is given by what is the current state of this process. Is it running? Meaning, is this process in the CPU, or is this process awaiting for something else to happen? Like, for example, if the process is, let's say you open a program called Microsoft Word. So when you open the Microsoft Word, you get the first screen that is called a process, but you have not typed in anything. So now that process is in the waiting state, because it is waiting for the user to actually type in something. Okay, so what is a running state? A running state is when the user is typing something and the process is still running, is still going on. Or maybe you are you are saving the files. Once you have used it, you want to save it. The process of saving the information about the file inside the process is what we see as it's in the running state. And it is terminated, so now the process goes back to the hard disk. And then you have what are the registers associated with this particular process, what is the main memory, where is it located, what is the address of the main memory, and what are the files associated with this process. So 1, 2, 3, 4, 5, 6, 7. 7 states of process, and I encourage you to memorize all. As a process executes, it changes a state. Okay, as a process executes, the state of the process changes. So what is the state of the process? The state of the process is either new, ready, running, waiting, or terminated. The state of the process is defined as, the current activity that the process is doing. Only one process can be running at any processor at any instance. Many processes may be ready and waiting for their turn to be processed. Okay. Point number 3 and 4. Okay. As I mentioned just now, the operating system is capable of doing multitasking. So multitasking is a situation whereby the operating system can do multiple processes at one particular time. However, statement number 3 says only one process can be running on any processor at any instance. So this contradicts to what I've said. We said that the operating system can run multiple processes, but the statement here says you can only run one process. So how is this possible? Actually, what happens in multitasking is the process is run so fast that each process might only take 1 millisecond. So it switches between a few processes, and when it switches, the user does not know that it's being switched to a few other processes running at a particular one time. So that's why the processor can only run one process, but it actually is switching between multiple processes, and each process only takes some time, about 1 millisecond. Okay, so when it switches to a different process, the current process, which the previous process which was running, goes inside the memory, wait, and automatically once the current process finishes its 1 millisecond, it goes back in, and the rotation happens. So what is the states of the processes? So we have a new state, running state, waiting state, ready state, and terminated state. So new state is in the hard disk. Okay, so note this down. The new state is inside the hard disk, whereby the process is being created. It is not created yet, but is being created. So that's why we say it's still inside the hard disk. The running process is whereby the process is now being run. It's now being processed. Okay, so it's now being executed. So this state is now inside the processor or inside the CPU. The waiting state is whereby the process is waiting for something to occur. Normally, it's waiting for an input-output condition or a signal. Let's say you use Microsoft Word and you are printing. Okay, so there's nothing else to do but wait for the printer to accept your request. So now the process goes inside the waiting stage. So the waiting state is also inside the main memory or inside the RAM. Same for ready state. The ready state is also waiting to be assigned to the processor and is located inside the main memory or RAM. And once it finishes, it's called the terminated state, whereby the process goes back to the original location, which is inside the hard disk. So this is how the diagram looks like of the process state. So this circle here, new, is inside your hard disk. So we have a process called, a program actually, sorry, called the job scheduler, which will admit the process inside your ready queue. We call this a queue. Okay, this ready queue is inside your memory. And then once the running state is, which is inside your processor, your CPU, it's free. The process from here goes inside your processor or your CPU and it begins to run. Once it's finished, it will come out and it will go out here. Let's say there is an input output while it's running, it's waiting for an input output. What does that mean? For example, let's say your program needs an input. Okay, an input. The input needs an input by the keyboard. That means it needs the user to type in something. So it automatically goes inside a waiting state. Where is the waiting state? It's inside your main memory or your RAM. And it waits for the input output to come, or maybe it's waiting for an event to have complete. Only then it can go. For example, it's waiting for the printer to print the previous document. Only then it can go in. So that's also a waiting state. And so it's waiting inside the main memory. And once it's done, it goes back inside your ready state, and the cycle continues. Okay, so we have a job queue here. So the job queue is actually to take all the processes from from the from the system that are waiting to be moved inside your memory. Okay, so the job queue will allocate or will take in all the processes which is inside your hard disk and move it inside the ready queue, which is inside the memory. On the other hand, the ready queue sets of all processes inside the main memory and is now ready to be executed by the CPU. And you also have the device input output queue, set of processes waiting for an input output device. Okay, this means this process cannot continue because they are waiting for an input output to occur or to finish. Okay, there's nothing wrong with the process, but the process requires them to get an input output from something else or wait for the input output to complete, and then they can continue finishing. So this is a job queue, a ready queue, and CPU. So the job queue is inside the main memory as well as the ready queue, and the CPU is the processor by itself. So if there's a process running here and suddenly this process requires an input, so it goes back inside the queue, which is under the main memory, and it waits for that operating system to finish or event to occur or be free. And it goes back inside your ready queue and it goes back inside your CPU. So there are two types of three types of schedulers, which is the long-term scheduler and the short-term scheduler. So what are these schedulers for? So let me just show you, read the, the description later, but I will show you the needs so that we can get it. Okay, so you have this ready queue. Let me show you in this diagram. This diagram is better. Okay, so you have three types of queue: short-term and medium scheduler. Right? So the long-term scheduler meets process from your hard disk to your main memory. So this is long-term scheduler. What is a long-term scheduler? Is it a program? Yes, it's a part of the kernel program that it meets new program, new processes from the hard disk to the main memory. That is called the long-term scheduler. The short-term scheduler, on the other hand, it meets the process from the ready queue to the running or to the CPU. Okay, so this is long and this is short. Why is it short? Because it needs to move very fast. Like I said just now, the operating system runs multiple programs, multiple processes at one particular time. So if it's slow, then no process can be, you cannot have many processes running at one particular time. So the short-term scheduler needs to run in a short period of time, but constantly. Unlike the long-term scheduler, it can take its time because it only brings in program or processes necessary from the hard disk to the. We also have something which is called the medium-term scheduler. Medium-term scheduler. Medium-term scheduler. Okay. And then we also have a medium-term scheduler is from the ready queue. Okay, the ready queue to the running queue. Sometimes you also have, this is a long-term scheduler, this is a short-term scheduler, and you have a medium-term scheduler. Sometimes when the process is running, the process is being altered, not because of waiting for any input output, but because of some other issues. So from the running state, it automatically goes straight in without waiting for any input output to occur. It goes back to the main memory. So that is the job of the medium-term scheduler, to bring the processes from the running to the ready queue. Are you with me? I'm done.
Okay, sir.
We also have something which is called the context switch. The context switch is to replace the process and change it with another process. I will explain to you about this at the end of the slide because it's connecting with multitasking. So I'll explain it in the later part of the slides. Okay, so we have something which is called the single tasking and we have multi-programming. A single tasking is the processor is busy only when the user is executing the job. Okay, a single tasking means that the operating system can only run one particular task and not many tasks. But in the multi-programming environment, the processor must or can run or should run multiple programs at one particular point in time. Okay, so we have some scheduling policies which I've noted down here. Which process needs to be run first and which process can be waiting or can be altered. Okay, so there is a scheduling process because you have so many processes in your ready queue main memory. Which process to run? So now there's a job for there's an algorithm to choose from. Okay, we will cover that in later class. Okay, so inside the single task system, operating system, you only have one program executed at one time. Okay, so this is how your memory layout looks like in the main memory. You have your operating system files and you have the user program. Okay, so it runs only one task at one particular point in time. Okay, and then you have the single task is divided into two types of processing. One is the sequential processing and one is the batch processing. Okay? So sequential processing is whereby it's a single task, but it's done sequentially, meaning one after another. Okay? Example, when you're typing a command line, okay, meaning it does one process and then moves on to the next process, moves on to the next process. Okay, okay, it's doing one task, but it's doing only, okay, it's completing one and then moving on to the next one, moving on to the next one. What does that mean? Meaning to say it only does one process. It's not like it does process one, stop, move to process two, stop, move back to process one. No, it does not do that. It does the sequentially processing, but for one particular task. Okay, for example, just imagine you can only open Microsoft Office. You cannot open Office, you cannot open Excel and PowerPoint all at the same time. You can only open Excel only. Okay, so the process of loading the file is one task. Oh, sorry, it's one process. Okay, the task is to run Excel program. So opening the first screen is one process. Once the screen comes out, user clicks on file is the second process, and so on, so on, so on. It's single process at one particular point in time. Batch processing, okay, is a single task. However, it's done batch by batch. Straight go to the example, the customer does not receive a bill for each separate credit card purchase, but one monthly bill for all of that month's purchase. Okay, so it's one particular. Just imagine you are using the operating system, you're using your PC, but you can only do one task, and that task is done in a batch format. Meaning, even if you have several tasks put in, okay, you have several tasks put in a particular operating system, but you can only do all together once only. Okay? It's not going to do stop, 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 stop. No, it's going to collectively collect all and run it at one particular point. So that is why we say as a batch system. So this is how a batch system in the memory and TPU looks like. So you have a scheduler which is located inside the main memory, and your jobs are all there. So all the jobs will be collected inside the memory and run together once only. Okay? There is no switching of any jobs, but all jobs are run together once. So that is what we say. Next, we move on into multitasking. The ability to run more than one program is divided into two types of multitasking: multi-programming and time sharing. Multi-programming is much more easy to understand. It means you run multiple programs at one particular point of time. Time sharing, you run multiple programs. However, each program is given a certain point of time only. Meaning, after 10 minutes, you change to a different program. After 10 minutes, you change it to a different program. Multitasking is something like this. This first picture, he's sitting down, playing the flute, printing, playing the drum, and using the keyboard here, or typewriter here. Okay, and this is what normally you do on the second picture, the long blue here. You're listening, you're talking, you're playing games and everything, all at one time. So this is what we say is a multitasking. So in that multitasking, there are two types of version, batch and the non-interactive. So multi-programming increases the CPU utilization by organizing jobs so that the CPU has always one to execute. Meaning multi-programming, the CPU is always at its best. That means it's being fully utilized because there are so many tasks to run at one particular point in time. Okay, and some processes or some programs are batch and some are non-interactive. Non-interactive meaning the user has no control over that process. Okay, meaning, for example, the time, the antivirus. Okay, the user does not need to initiate. The user only needs to initiate that program, but the program will be done automatically. Okay, in multi-program, the operating system switches to another job and executes it. Okay, meaning it runs multitasking and it switches between jobs, between processes. As long as there is one job needs to be executed, the CPU is never idle. That means as long as there is one particular job to be executed inside the processor, the CPU will always be utilized. So this is multi-programming or multi-programming means we have a few jobs, few processes, all waiting to be executed, and this is how it looks like. It is all there's 4 jobs all inside the main memory waiting to be executed. So this is what we say as a this is what we say as a multi-programming. Next we see as time sharing, same as multitasking, but we have to remember each program or each process is given a time slice, meaning each process can only run for a certain period of time. After that, it needs to stop or it needs to take a break, and another process will continue. Okay. For example, next we also have another diagram here. You have application 1, 2, 3, 4. Application means process or processors, but all are assigned to the same CPU, same operating system, but all are given time sharing system, all are given a time command, meaning they can only run this program for a certain period of time. Next, we have what we say is a cooperative multitasking, and we have a preemptive multitasking. Okay, a cooperative multitasking is more of programming, meaning to say the system, the operating system relies on the process to run, meaning there is no given time for each process. However, the process itself, once it's finished, it will automatically give it to the next process. So this is cooperative. Once you finish paying, for example, once you finish using something, you automatically give the next person behind you to use that. Okay. Once you have paid for your food at the cafe, you ask the next person to come front to pay. That is cooperative. Preemptive meaning you stop temporarily, the process stops temporarily at one particular time, then the next process comes in, and then once the next process has finished, the previous process will come in and run where it stopped. Okay, where it stopped. Let me show you a diagram. This is how it looks like. Preemptive multitasking. We have 2 processes. So process 1 is now running, and it switches to process 2, switches back to process 1, switches back to process 2, switches back to process 2. So it continues, process 1 continues back where it left off. Okay, so it continues back. In a cooperative multitasking, process 1 finish, idle for a while, going to process B. You see, as you can see here, process B goes in for a very long period of time, meaning it finishes whatever it needs to be done, and then it goes back to process A because it's doing a cooperative manner. However, if this process, the only disadvantage of using a cooperative multitasking is if this process comes to an error, for example, a blue screen, okay, or the process hangs, then the operating system cannot do anything because it's the process which needs to finish, only then a different process can come in. So this is another cartoon picture of how multitasking is done. Okay, he is smiling here. I'm sure he's not supposed to smile. Okay, I explain to you, contract switching is how we do preemptive multitasking, whereby we save the last location or the last state of the process, and we go into a new process, and once we come back, we just continue previously on where we stopped. Okay, contract switching is something whereby this you have process 1 which is running from top to bottom, and it runs up to here, it's being interrupted, so we switch to a different process, and once we switch back to process 1, it continues back where it left off, not at the beginning, not at the end, but wherever it left off, it will continue from then on. Okay, and if there's another interrupt, it goes back and then comes out again. That's what we say. It's a preemptive. Okay, preemptive multitasking. This is a if you can read. Okay. So how does a context switch look like? It's the same as active multitasking. We have process 1 running here, and it gets interrupted, and the state of that process goes into PCB. But it's PCB, process control block, it saves the state, and then once it is done, it reloads, okay, because process 2 is coming in, reloads state in PCB2, and process 2 is being executed down here. Once process 2 is being interrupted, it saves the current state of process 2 and reloads back PCB1. PCB1 is here. Okay, reloads back and executes. Okay, so as you can see here, the CPU is also never idle as it continues doing so many things at one particular point in time. However, each state or each along the way, process changes among themselves. Okay, so that's all for today. All right, we have covered chapter 3.1. Okay, and I will put up this slides online so for you to look into. Don't forget to click on my attendance at ULearn, and you can view this video at my YouTube channel. I will upload it shortly. And if you have any questions, you can ask me now. Do you have any questions? No?
Inshallah, ada sir.
Do you finish your test?
Sir, regarding our test, is there anything we need to focus on, like specifically on chapter 1, chapter 2? There is anything we need to focus on, or just
Okay, for your test, chapter 1 and chapter 2, correct? Try to read more on the ending of chapter 2. Okay, the ending part of chapter 2. Make sure you also know the definition of operating system. Make sure you also know the definition of application software. The definitions will surely come out. But I can say that you need to focus more on chapter 2, especially the ending part of it. Okay, so do you know when is your test?
Saturday, sir.
Saturday, sir.
What time?
Night, 8:30 to 10:30.
8:30, not 8 o'clock.
Wait,
8:30.
8:30 kan? Yeah.
8:30, sir.
Okay, sure. I'm not sure. I have to check it. Okay, 8:30. Correct.
Alright.
Okay, all right. Thank you very much. If you have no questions, thank you very much. And inshallah, I will see you this Saturday. I won't see you, but I will put out the questions on ULearn, and you can get the questions from ULearn. And inshallah, I hope you well. And 8:30, yeah. I only thought it's 8 o'clock. Okay, never mind. I will double check and let you know through my WhatsApp.
Sir, there's no attendance in near future.
Oh, there's no attendance today?
Attendance tak ada dekat YouTube.
Oh, okay. Give me 5 minutes. Once this I stop this, I'll create the attendance for today. I'm so sorry. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Waalaikumsalam.
Thank you, sir.
Yes, sir.